Welcome. My name is Ron Schmidt, and I'm the creator of the Net Zero Now YouTube channel. And today is going to be video 12A. It's part of the science section under atmosphere, and it's going to be an overview of jet streams. And I've entitled the video Jet Stream Roulette. So let's begin. I'm going to, in this video, cover 4 topics. One, I'm going to talk about and conduct a high-level overview of Earth's jet streams. And then I'm going to do a detailed review of the 2 permanent jet streams, which is the polar jet and the subtropical jet. And I'm going to talk about how that influences weather in the mid-latitudes. And then the third topic I'm going to cover is then how climate change is impacting both the polar jet and the subtropical jet, and how that impacts weather in the mid-latitudes then. And then I'm going to talk about why I use the term roulette in the title, okay? So let's begin. So what's a jet stream? A jet stream is a narrow flowing river of air located in the upper atmosphere, and it plays a critical role in steering weather systems and sort of influencing global temperatures. So the next question is, how many jet streams are there? Well, there's sort of 6. There's 2 major ones, or permanent ones, which I'll call the polar jet and the subtropical jet. And then there's 4 major seasonal ones. That would be the tropical easterly jet, the polar night jet, the African easterly jet, and Somali jet. And we're going to cover each one of those in a little bit of detail here next soon. Now, if you take a look at the jet streams, the ones I want to talk about in terms of the permanent jet, you can see this visual that I've used in some other diagrams that shows where the jet streams are. And in the major video in the middle, let's start at the bottom yellow line, or the Intertropical Conversion Zone, the ITCZ, which is basically the thermal equator, okay? And up from that, about 30 degrees, just at the intersection between the Hadley cell and the Ferrel cell, is the subtropical jet. And then if we go up another 30 degrees, and you go between the Ferrel cell and the polar cell, you'll see the polar jet. And that's roughly where they exist. Now they show, in the major diagram in the middle here, as straight lines. If you look to the illustration in the upper right-hand corner, you can see that they really are wavy, and that the polar jet is much more wavier than the subtropical jet is. And if you're interested in how Earth's circulation system really operates, I've already done 2 videos on that, called Atmospheric Circulation Part 1 and Part 2, and we'll talk about the Hadley cells and all the terms that you see here in this illustration. So if you're interested in more detail, and I think it's really fascinating, I would highly recommend you look at those videos. Okay, so what's the role of jet streams in Earth's atmospheric system? And I think, sometimes we think of jets as streams as just sort of like wind. Isolated wind kinds of things, but it's really not. They are sort of the primary circulation system of Earth's atmosphere. And they really sort of for 4 sort of functions. When they're there, they balance the planet's energy balance, that is moving heat from the equator towards the pole to sort of balance that out a little bit. And then the second thing, they serve as the master architect of global weather patterns. So the weather we experience, wherever part of the globe you have, is fundamentally determined by what happens with the jet streams. And they act as a dynamic boundary between vast bodies of air. Like the Hadley cell is a massive body of air that goes between basically 30 degrees latitude from the equator to the horse latitude. And then you have the Ferrel cell and the polar cell. These are massive, and so the jet streams sort of are these boundary lines between those. And they regulate everything. I mean, they determine the arrival of our things like the monsoons, the birth of hurricanes, they steer our storms, they sustain the world's water supply. So they're really critical to what's going on here on Earth. And do the different jet streams have different roles? Yeah, they do. The polar and subtropical jets sort of act as sort of the year-round framework for everything that goes on in Earth's atmosphere. And then think of the seasonal jets as sort of seasonal things that just sort of add a spark that sort of kick off sort of regional sort of weather cycles. And so if we go to the permanent jets, let's talk first about the polar jet. And its sort of role here is it's the thermal regulator. So what it does, it separates the frigid sort of Arctic air from the milder mid-latitude air. It directly influences surfer weather patterns. So if you live in the mid-latitudes, what determines what kind of weather you get is fundamentally driven by the behavior of the polar jet. It guides severe storms as they constantly adjust their position, and it sort of regulates the what they call the meridional or the north-south transportation of heat. Now, in terms of the subtropic jet, think of that as a moisture transport. It's sort of the conveyor belt that moves moisture and heat or water vapor from the tropics into the mid-latitude areas. And then we have the regional jets. Now, for both the, I didn't say this in the last slide, but for both the polar jet and the subtropical jet, I'm going to do separate videos which will take a deep dive into their behavior, how they're formed, all these kinds of things. So I'll just go over that at a very high level here. If you're interested in more detail, look at those videos when I create them, and they won't, won't be too long from the time this video is released. And then we have 4 seasonal jets, and I'm going to do the same thing for each one of these 4 seasonal jets, and I'll sort of release them when it's sort of pertinent to a particular topic that I'm talking about. So listen, I'll just go through this quickly and talk about them maybe in terms of how they impact sort of weather that we see, their climate role. So if you take a look at the Africa easterly jet, its main role in the climate, it creates what they call African easterly waves. That is what is the seedlings, or what start almost 85% of the hurricanes we see in the Atlantic. And I'll cover that in a video I have on hurricanes, and when I release that video, I'll also do a separate one on the East Africa jet. The tropical easterly jet is another summertime one. It determines the strength and timing of the Asian monsoons. And then we have the polar night jet, sometimes referred to as the stratospheric jet. It's a wintertime only one, and it's what determines whether we have what they call a polar vortex periodically, where we get this extremely cold weather coming into the United States. And so, for example, right now, the time I'm doing this video in February of 2006, we've just experienced a polar vortex, which has really brought deep freezing weather all the way down to Texas. And the root cause of that is really the behavior of this polar night jet. And so I'll cover that in a separate video, and I'll probably be releasing that fairly soon, because I'm doing the next video I'm going to do is sort of talking about what caused the weather we've experienced in January, and late January and February of 2006. And then we have Somali jet, and it's sort of the moisture transfer for the South Asian monsoons. And this one is really highly sensitive to the behavior of ENSCO, which is El Nino or La Nina. So that basically is a quick high-level overview of what's happening with regard to the jet streams. I mean, overall. So now let's dig a little more deeply, I should say, into the polar jet and the subtropical jet and how they influence weather. So if we take a look at the next slide here, you can see on the upper right-hand side, here's another view of the subtropical and polar jet. You can see where they sit between the Hadley and Ferrel cell, etc. And you can see also that the troposphere is higher in the tropics near the equator than it is near the pole, and that's one of the major reasons for that is as temperatures get colder, the air compresses a little bit. There are other factors involved also, but I just want you to get a sense of that. The other thing is I'm talking frequently about the mid-latitudes. And if I want you to take a look at this map in the upper left-hand corner, and if you go to the northern hemisphere, you can see the arrow there between the 30 and 60 degrees latitude. And you look across, you can see it covers almost the entire United States, almost all of Europe, parts of Russia and parts of Asia, almost all Russia and really parts of Asia too. And if you look at the southern hemisphere, you see there's hardly any. It's almost ocean, almost all ocean down there. So when I talk about weather impact in the mid-latitudes, I'm really talking about the northern hemisphere, where so much of the population is affected by the behavior of the jet stream. And then here are some characteristics of the polar jet and the subpolar jet stream. Most of those we've talked about already. I would say one of the if you go down to the characteristics line, the polar jet is stronger and more variable and significantly meanders more than the subtropical jet. And it has trouts and ridges, and we'll talk about that a little bit later in this video. And then in terms of wind speed, the polar jet is faster than the subtropical jet. In terms of influence, weather influence then, sort of the polar jet sort of directly influences surface weather patterns and guides our weather systems, whereas the subtropical jet sort of is really like a significant moisture transfer system. So it brings the moisture and to some extent heat into the mid-latitudes and other things that we use to create, that we experience in some of our weather. So let's move on to now getting into a little bit more detail on the polar jet. So the polar jet, we said, is the master architect of our weather. It steers storms and it regulates temperature shifts. And the other thing it does, it sort of fuels the development of extreme weather events through large atmospheric waves, which are called Rossby waves. Now, in terms of the impact, we'll talk about a few major items here. The first is, let's say, the atmospheric steering of current, okay? It's conveyor belt role. What it does, it directs the movement of low pressure systems, which generally can turn into cyclones across the continent. And it does a couple things. One, it determines the path. So the storms sort of follow the path of the jet stream. The jet stream moves from east to west. And it has seasonal shifts. In the wintertime, it strengthens and it moves further south. And in the summer, it weakens and moves further north. Number two is that it fuels storm development. This is sometimes called cyclogenesis. And it actively intensifies storms throughout regions with high wind streaks, which are called jet streaks. These occur within the jet stream itself. So if you think of a jet stream, maybe think of a meandering river. And you know, sometimes in rivers you see these really fast currents where some portion of it is meandering. Think of a jet stream sort of like that. And when these jet streaks, not stream. And so when these jet streaks sort of accelerate and decelerate, what they do is they cause, as they spread out, they take air and they pull air up into the upper atmosphere, and it just sort of spreads out. It just sucks, and that process of doing it just sort of sucks air from the surface up into the upper atmosphere. And that's really what creates these intense low pressure systems, which lead to very powerful storms and blizzards, etc. And then the other thing that can occur here is you can have vertical wind shear that occurs as a result of that. So what that does is so normally the wind is flowing from west to east, right? But with these jet streams, as they pull this air up, what it does, it sort of causes the air to shear or move vertically. And this vertical movement is what's necessary for the creation of severe thunderstorms, because it pulls moisture way up into the atmosphere where it cools rapidly, and as the higher up it goes, the colder it gets, so you get more intense storms. And it also creates the lift that's necessary for tornadoes to occur also. And then here are some other factors. It regulates temperature through Rossby waves, which is a difficult concept to sort of get. And it produces what they call troughs and troughs and ridges, okay? And you can see an illustration on the right-hand side of that. You can see what they call the trough is where it's deep, it's headed, it has a deep southern dip to it. And you can see there's sort of an orange thing in a blue area there, and those are areas where you will see moisture forming for storms and other kinds of things. And then you can see a ridge. Like if you take a look at the map, you can see like through the state of Wisconsin would be the upper ridge of this. And in ridges, it allows warm tropic air to surge northward. And in the summertime, they can create intense heat waves, etc., and stuff like that. And the map and the illustration below just shows another visual aspect of that, where you have dry and cold, and in wintertime you'd have rain and snow, etc., as you go between the ridges and the troughs. Between the troughs and the ridges, excuse me, I'm having trouble pronouncing that today. And the other thing that can occur is you can have blocking. And what that means, sometimes as they're going through this waviness, they stall. And when they stall, weather patterns can actually last for a couple of days, sometimes a week. Sometimes it actually blocks, and it means it just almost stops. And that's when that occurs, you can get some really major events, like the 2021 Texas freeze was because a trough funnel was really formed over the southern United States and sort of stalled there. So that takes care of the polar jet. Let's talk real quickly now about the subtropical jet. Again, it's sort of, look at it as a moisture artery. It's two things that moves energy or heat and water vapor into the mid-latitudes from the tropics. And sort of that conveyor belt. And part of that is, you can see it in atmospheric rivers, okay? And I'm going to do a separate video on atmospheric rivers here shortly. And there's one atmospheric river called the Pineapple Express. That's where this atmospheric river, sort of stream of moisture, runs all the way from Hawaii directly into the west coast of the United States. Sometimes it hits California, sometimes it hits California, Oregon, and Washington State, etc. And we've all seen illustrations of that. So that's called the Pineapple Express. That would be an example of this. And this moisture river, so even if it's not a atmospheric river, it can provide massive amounts of moisture to particular areas, which can lead to prolonged flooding, etc. Then the other thing that can happen with jet streams is that what they call jet phasing, and this can lead to superstorms. And probably the most catastrophic weather we see in the mid-latitudes occur when the jet streams, when the subtropical jet and the polar jet sort of merge or in phase with one another or above one another, etc. And when that happens, they get massive amounts of synergy, okay? And because the polar jet sort of provides this dynamic lift of cold air and spark, and the STJ provides sort of latent moisture and heat, and this fuel just can create massive storms when they're linked up and one top of one another or even merged together. And when that happens too, and you get these massive storms, sometimes that's called cogenesis. I mean, it just occurs very rapidly. And so when you see powerful nor'easters and things like that, that's typically what's happening. A couple of other things. You get severe weather and wind shear. So because the subtropical jet is higher and much higher up, and so when you get, what can happen is that air in the subtropical areas near the jet stream can actually rise higher. And when it does that, you get sort of enhanced wind shear. And this wind shear is what creates updrafts, just like we talked with the polar jet, where you can get this updraft, which can help cause tornadoes and things like this. This just reinforces that when the same kind of thing happens with the STJ. And then it has a seasonal and interannual shifts that occur. Um, and that's because what they call ENSO, or think of it as La Nina and El Nino. Uh, um, and when that occurs, what happens is you can get these significant changes in behavior that occurs to the subtropical jet. So, for example, in El Nino influences, during the El Nino years, the subtropical jet strengthens and shifts south, typically bringing wetter than average winters to the United States and California. And then the reverse happens in La Nina cycles, okay? And then the other thing is the subtropical jet plays a particularly large role in terms of air transportation. But it also can cause what can occur there, and what's happening is with temperature change, by the way, is we're getting more variability, more clear air turbulence that's occurring in these jets. But gets ahead of myself here a little bit. So we sort of now talked in a little bit of detail about the polar and the subtropical jets. So now I want to move to how climate change is impacting the behavior of both of those jets, and then how that in turn is influencing the weather in the mid-latitude area. Okay, and so if we look at this, let's say you really have two factors going on here. You have the polar jet, which is meandering more, and you have the subtropical jet, which is sort of strengthening a little bit, but it's getting higher and pulling in more moisture and more heat. So you got those things sort of tug of war going on there. So the impact on the polar jet, let's talk about that first one. And the major thing here is Arctic amplification. You'll hear that term. What that means, if you take a look at the graphs below, what that means is that the temperature in the Arctic is rising faster than it is other parts. That means the temperature differential between the Arctic air and the equator, etc., is decreasing. And since the behavior of almost all the weather systems or jet streams is influenced directly by temperature differences, as those temperature differences change, particularly for the polar jet, it causes their behavior to change. And you can see from that graph, the middle chart there just shows that temperatures are rising. They're rising in the ocean over land and Arctic, but you can see how much faster they're rising in the Arctic than they are over land in the ocean. And then I have two videos I've already released. If you haven't watched them, I highly recommend you do. It talks about why we need to get the net zero greenhouse gases and explains this impact in terms of weather. A little bit more detail I'm going to cover here. But let's say that behavior of Arctic amplification really is resulting in a weakening and the slowing of the jet stream, increased waviness or meandering of the jet stream, and results in periodic atmospheric blocking. Okay, the impact on the subtropical jet, and we talked about that a little bit. And so one thing is there's polar expansion that's actually going on now, and that the Hadley cell area, or the tropical area, is really increasing slightly. And it's been increasing by 1 degree latitude, which is really a lot of area if you think about it, every decade for the last few decades now. And that's because temperatures are warming. Greenhouse gases are causing that to occur. And also it's strengthening. And that's doing, this increased heat is causing the jet stream to the subtropical jet to actually go higher and move faster. And it's actually slowing the polar jet, which is meandering more. So you have these conflicting behaviors there. You get weather whiplash. A wavier polar jet with and a shifting faster subtropical jet leads to more rapid transitions then between extreme weather conditions, okay? And we've talked about some of these already, so I'm not going to go over it. But what's important here, what is causing that behavior, is the increase in global temperatures and Arctic amplification. So the impacts are, and we've talked about those, so I'm not going to go over them a lot, is more persistent extreme weather, weather that stalls for a while, extreme cold outbreaks, shifting of storm tracks northward as the subtropical jet moves northward. And this is the last one, it's a really important enhanced phasing or more frequent linking of those two jets, which then in turn results in really massive superstorms. And then the last thing it's affecting is sort of the vertical structure of the atmosphere, and also it's impacting the interactions with the stratosphere. The rising altitude, the increased verticality, can lead to stronger storms. We've already covered that in the past. More vertical lift, higher areas of higher altitude means you have taller storms or bigger storms. And then we also talked a little bit about the impact of the polar, how temperatures are impacting the stratospheric, or the polar night jet would be a better way of saying it. And when I recorded this video in January, from early February of 2006, we just went through a major polar vortex in the United States, which brought massive cold weather and then some storms here. That is all caused by the behavior of the polar night jet. And again, as I mentioned before, I will release a video almost simultaneously with this one, which will talk about that in more detail if you're particularly interested in that. So we've now covered how, at a quickly high level, how climate change is impacting the behavior of the subtropical and polar jet, and how that in turn then is influencing weather in the mid-latitudes area. So let me just go through quickly why I use the term roulette. And you can see I've got two kinds of roulette here. One is sort of like a casino roulette, and there's what they call Russian roulette, okay? And the reason I use the term roulette is that there is a randomness to our weather that's just almost impossible to predict. So we know, for example, for sure that temperatures are increasing, the Arctic amplification is real, and it's impacting the behavior of all these different weather systems. But where the weather system ends up has a huge impact on how much damage it causes. For example, we just recently had no hurricanes hit no hurricane damage in the United States for over $1 billion in 2025. We had 4 major hurricanes that occurred in the Atlantic. 3 of them were Category 5 hurricanes, which is really very unusual. And that the reason they're so intense is because of climate change, higher water temperatures, etc. But they didn't hit the United States, and that was because low pressures and high pressures happened to be sitting at that particular point in time. So it's a randomness to it. Now, if you're in Columbus, Ohio, and you hear of a hurricane, you start to say, well, okay, I guess that's sort of like a casino thing. I'm interested in that. But if you happen to be in Jamaica in 2025 when it's hurricanes hitting, it's like Russian roulette. Or if you were in New Orleans when the hurricane hit, Katrina hit, it's like Russian roulette. And that's the point I'm trying to make here. And I'm going to tell you, if it had been just for a little, the high pressure and low pressure, it's just been a little bit different location, these Category 5 hurricanes would have made it into the Gulf of Mexico. And if they had gone up through the United States, they would have caused hundreds of billions of dollars worth of damage. So the Category 5 hurricanes are happening. It just so happened this year we were lucky. Maybe next year we won't be. And that's why I use the term roulette. And just to give you an idea of some of the other things that influence that, I want to say here are some large-scale atmospheric oscillations that can impact the polar jet. I've named them. I think there's 8 of them here. I showed the primary mechanism and the typical impact on the polar jet. I'm going to do separate presentations on each one of these. And if you're interested in that, I would suggest you just pause the video and read it or look at the ones you're interested in. In the interest of time, I'm not going to go through those right now. I just wanted to show those to you to show you how many other factors can affect the behavior of our weather. And then in addition to those, there's some other major things that could impact it. We talked a little bit about Arctic amplification And there are some other ones that are like solar cycles, ocean heat, volcanic activity. I showed the primary mechanisms here, and then you put the primary effect on a polar jet. Again, if you're interested in that, pause the video. You can look at it. I will eventually do, when it's appropriate, videos probably on each one of these. So let's get close to wrapping this up. I just wanted to get close to ending here by showing this video I've shown frequently. And it says the future is coming. Okay, what the client scientists are telling us is that when we hit 1.5 degrees Celsius from pre-industrial levels, that occurred at the end of 2024. It said there will be significant environment, economic, and social impacts. And if you were alive then, you know that's happened, okay? And it says if we get to 2 degrees Celsius, which may be within 10 years, the world will see catastrophic and likely irreversible damage. And take a look at what's happened in 2025. We've had more severe storms. Now in 2026, we're off to a flying start. So I think that is very credible. And I guess I'm saying, we need to pay attention to what the scientists are saying. But even more alarming, why this is so important, is that look at tipping systems. So that says that when we reach that level, almost 90% of the Earth's tipping subsystems will be tipping. That means they're in their tipping range. One example would be Greenland. Greenland's always reached probably its tipping point where we no longer can probably prevent it from eventually thawing. Now, it may take hundreds and hundreds of years to do that because it's just the massive size of the ice. But it's in the tipping process, and I've got videos that talked about that. And so, if you're interested, look at some of those prior videos. So I just want to bring this up to say, hey, this is real, folks. We need to pay attention to it. And then, lastly, I just want to do a quick ending here. So, recap: we talked about, give you a high-level overview of the jet streams. We talked about, in a little bit more detail, the permanent jet streams, the polar jet and the subtropical jet. We talked about how climate change is impacting that and how both jets sort of impact the weather within the mid-latitudes area. And we talked about why I used the term roulette when I said for this particular video. Point B, I just want to make this clear so we don't forget about it when we're talking about all these other things. The only way we are going to prevent just some major disasters to Earth's weather and living conditions. The only way to prevent that is to get to net zero greenhouse gases, and we need to do that now. And by now, I mean as fast as humanly possible. So, my question to you is, so you got this information, what are you going to do about it? Excuse me. One thing I want to do is suggest that you vote in every election at every level of government. I mean, the only way to solve this problem is we need to get elected officials who believe that climate change is real and are willing to take action to do something about it. And then they also need to have the personality and leadership characteristics where they're willing to work with other people to solve this problem, because it's a worldwide problem. We can't solve it by ourselves. And then you can subscribe to this video and do some other things. And let me say one thing. When I talk about all these videos, I'm mostly looking at it from a systemic standpoint. But there are individual actions that all of us can take that are important, and I encourage you to do that. I think you know what most of those probably are, like recycling and doing things like that. But get involved in your local communities, understand those things and do those kinds of things. They're really critically important to you. And then lastly, I sort of just showed this video. I have this picture of the top shot of somebody shooting at a shooting range, gun at a shooting range. That's probably inappropriate. But anyway, the reason I did it, I just want to make a point. I mean, I'm an old man, so, some of the stuff isn't probably going to affect me. But, if we don't pay attention to this, what are we doing to our future generations? I mean, are we taking a gun, are we shooting, just taking target practice here? Are we really doing that to our kids and grandkids? And so I think this is really an important issue that needs to be addressed. And just thank you for listening to me. I appreciate you listening to these videos, and hopefully you'll join us for some other ones. And have a great day.